So you may have gathered from the previous video that it can be difficult to write assembly language code, especially if you haven't done it before. Now we really need something to help us, and that's what we've got in this video. I've created an assembly language debugger. I've written it in Excel Visual Basic for Applications, that's VBA. Now I'll show you how to use this debugger, and in the bonus section I'll actually go over all of the code so you can see how the code works. I haven't gone over the code here in this video because it took me about a week to write the code, and it'll probably take a couple of videos to go over the full code. But at least you've got something here that you can use that will help you write your assembly language programs. So good luck. If you go into the resources section, you'll see there's a file called Assembly Language Debugger. So you can go and open that up. Now when you open it up, you'll have this page here. And there's two tabs at the bottom, one called Debugger and one called Sample Programs. So if you click on the Sample Programs one, you'll see that I've got two here sitting at the moment. One's called the Fibonacci, and it works out this Fibonacci series. And the other one is Multiply, which is to multiply two numbers together. So we've seen this multiply one previously. So what we can do is we can copy that, Control C, open up the debugger, and we can place it in here. So Control V. So that's in columns B, C, D and E. Now if we click on Assemble, it will create the assembly language code for it. And then whenever we click Debug, it will work through each row individually, and you'll get all of the values here that we're interested in. So for example, we're going to have the actual step that it's on, so the actual code that it's running, the instruction address register, the instruction register, the registers are 0, 1, 2 and 3, the carry out, the A greater than B, A equals B and the Z. So this is the flags here and the registers, and we've also got the memory locations here. So let's go ahead and we'll just press debug and we'll see this running. So you can see here that it's starting to work through each and every line individually, and you can see all of the registers changing and all of the flags changing, and you can see it jumping as well when it gets to the jump carry, and you can see how the program actually flows. So I've set this out so it's running slowly at the moment so you can see it, but if you just press escape then it will run through a bit quicker. And obviously because I'm recording this, my computer is running a little bit slower. So that's it finished there, and you can see that the answers in the register R2, which is multiplying the two numbers together, which is 5 times 5, which is 25. So now the whole point about this is that what you could do is you can build up a program slowly. So for example, you could do just one line at a time. So you press Assemble and Debug, and it'll do just that one particular code. So this code here, it's adding the value 5 into the register given by RB, which is R0, so it puts 5 in the register here, and you can continually add up and add lines to this until you've got the entire code built up. And it just gives us you a way of designing your code one little step at a time. So now whenever you've finished your code, so let's say for example I actually worked on a code called the Fibonacci series, so this is it here, so I can Control C and I can paste it in here, and if I was to assemble it and then press the debug, and you'll see it running through the debugger, and press escape and it will run through a little bit quicker, and it actually generates the Fibonacci series here, and you can see the numbers being generated. That's a 3, 5, 8, 13, 21, 34, and it will go all the way up until it gets to a number that's just less than 255. So if you press Well, that's it finished now, so the final number was 233. So now we can take this code here, and if we want to run it on our CPU, we can click on our export, and then we can put our file name in. So let me go ahead and I'll do that just now. This debugger is not a finished article at the moment, and I will be working on it and will be upgrading it, but you can use it in order to build assembly language programs. If you want to have a look at it, you can go into the developer section and you can click on the view code, and you'll have access to all of the code there. Now, as I said, it's not at the moment completely finished, and the code can be done. I could do a lot of optimization on the code, but if you know some VBA, then you can also always go in and have a little look at it and see exactly how the code was put together. So in effect, what this does is it models the CPU, and it models it well enough such that whenever you write out the code in the debugger, we can save it and export it, and we'll be able to load it into the CPU, and it should run exactly the same in the CPU as it does in this debugger. Now, if I was to work through and describe all of the code, it would probably cover 4 or 5 videos. So I'm not going to do that here, but what I will do is in the bonus section I'll cover it in detail. So the main point about this video here is that you have access to a tool that you can use that will help you to write assembly language programs. And I'll also, in the bonus section, add in some extra examples. So for example, I have the Fibonacci series done. I'll also look at doing the highest common factor, which is one of the problems that we had looked at earlier on in the course. That's all there is for this video. I suggest that if you want to get some practice writing assembly language for our CPU, you could open up the debugger and you could work through the example I have there on the Fibonacci series. If you don't know what that is, you can always go onto Google and have a look. And you could work through that and you could see exactly how that code works, and it's just a simple algorithm, and it'll get you used to using the debugger. Also, try and work out a few examples of yourself. For example, the highest common factor is a good one to try. So thank you for listening. I'll get you on the next video. Goodbye.